welcome back to day 2. So we are on the next slide of the 8-1 notes, picking up where we left off with Pythagorean theorem yesterday. So if you haven't found your notes yet, if you don't have those out, pause the video, find your notes, and go to the page starting with Pythagorean triples. So Pythagorean triples are special cases of 3 number sets that form sides of right triangles. What I'm going to show you today is shortcuts. Shortcuts are really, really handy, especially on standardized tests. And Pythagorean triples are frequent occurrences on standardized tests such as the ACT. You also will see them frequently in homework assignments, even when we get into area formulas in later chapters, surface area volume formulas in later chapters, trigonometry. We see them a lot in trigonometry, which is something we'll get into at the end of this unit. And they really are just a time-saving device. I'm going to preface this with, you can always solve for missing sides using the procedure we learned yesterday. So a squared plus b squared equals c squared, substitute in 2 numbers, solve for the third one. So if the triples trick doesn't work for you, work it out the long way. The formula itself will always work. So now for the shortcut. So Pythagorean triple means 3, is a set of 3 whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no fractions, no decimals, no weird stuff, that satisfy the Pythagorean theorem, a squared plus b squared equals c squared. Some examples: 3, 4, 5. Now, you don't need to write this part down, just a sort of a side trip. If I had a triangle with legs of 3, 4, and 5, and I set up the theorem 3 squared plus 4 squared equals 5 squared. 3 squared is 9, plus 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. If we substitute those sides into the Pythagorean theorem, the 2 sides will be equal. So a triple is formed by 3 numbers that make this equation true, which in turn gives us 3 sides of a right triangle. 3, 4, 5 is the smallest and most commonly seen triple in trigonometry and on standardized tests. It pays to memorize that 3, 4, 5 is a triple. Another is 5, 12, 13, probably the second most commonly seen triple. 25 plus 144 equals 169. A squared plus b squared is equal to c squared. This one is also worth memorizing. A third one is 8, 15, 17. Another commonly seen item on standardized tests. 7, 24, 25 is the fourth one. And there are many, many more. There's a poster in my classroom that has several of these on it. It has to be covered up on exam days, but it's there for reference in the meantime. There are others. 9, 40, 41 is another one. It's less commonly seen. Most students don't have that one memorized. 11, 60, 61 is another one. But really, it's these first 4 that you see the most often. And the list goes on. There are infinitely many of these triples. And many of them we don't recognize when we see them. If we are given a picture of a triangle with 2 sides and we have to find the third side and those numbers are bigger, usually we just use the formula to work it out because we don't recognize the sides. But what we want to shoot for is if we see a triangle in our homework that has legs of 3 and 4, we automatically know that the hypotenuse is 5 without having to work it out. So it's going to save us some time working out problems if we just know these triples. So what I encourage is for the first 4 anyway, try to memorize these. it's going to shave some serious time off your work in the long run if you just know them from memory, particularly the first ones. Okay, as a little added bonus, any multiple of a triple is another triple. You take any one of these triples over on the left and you multiply every number by the same constant, you get another triple. So you could take 3, 4, 5 and double each of those numbers to get 6, 8, 10. That still makes a right triangle. 36 plus 64 is equal to 100. And it's because when you scale up, when you multiply by the same thing, you're scaling up the triangle. The angles are still the same. Sides are proportional, angles are the same. It makes a similar triangle. Therefore, it would still be a right triangle. 6, 8, 10 is another one that is commonly seen on standardized tests. It'll pop up in your homework several times over the next few weeks. You take 3, 4, 5 and multiply by 3, you get 9, 12, 15. Take 3, 4, 5, multiply by 4, you get 12, 16, 20. Still a triple. So scale any, you can take just one of these, 3, 4, 5, multiply by any whole number and make a new one. So you can get infinitely many just from the first one. You can double the 5, 12, 13 and get 10, 24, 26. That's another triple. Multiply by 3, 15, 36, 39. It's still a triple. Take 8, 15, 17 and double it. Or better yet, multiply by 10. You get 80, 150, 170. That's still a triple. There was a problem in our notes yesterday. They had a triangle, a right triangle with sides of 30, 40, and x. 30 and 40 are multiples of 3 and 4. If you multiply 3 by 10 and 4 by 10, you get 30 and 40. So if you multiply 5 by 10, you can get 50, and this is a 3, 4, 5 triple that's been scaled up by a factor of 10. So 30, 40, 50 is another triple. I just found that missing side without doing any computations at all, other than multiplying by 10. So any triangle for which the side lengths are all 3 whole numbers, there's a triple in there. And a lot of times those triples are recognizable and we can see them without actually having to write out 30 squared plus 40 squared equals x squared and do the work. We save ourselves all this work by just knowing those triples. So the goal for today is to try to learn to recognize triples that commonly occur and use them in a clever way to solve for missing sides without having to show any work at all. And I know that some of you don't like to show work, so this is going to be right up your alley. Alright, go on to that next slide, and I'm going to show you my fishing for triples trick. So this is not an official terminology. This is Miss Rice's words. I'm going fishing for triples. So I have 6 triangles on this sheet, and I want to find the missing sides, and I want to do it without any a squared plus b squared equals c squared long computations. Now, let me remind you, it is okay to do it the long way. If you want to take this triangle right here and set up 8 squared plus 15 squared, 8 squared plus 15 squared equals x squared, and solve it the long way, you absolutely could do that. It always works. It's just more work. If you want to do it the long way, feel free. But I'm going to teach you a shortcut. Use it or don't use it. It's entirely up to you. Okay? So I'm going to skip the long way, and I'm going to do it the short way. So for this very first one here, 8, 15, 17, if I look back at my notes, I'll notice that 8, 15, 17 is one of those triples. So since I have 8 and 15 for the two legs, and the legs have to be the two shorter sides, that means this hypotenuse has to be the 17. So if I know this triple, I already know that x equals 17 feet. And I'm finished without doing any work whatsoever. Okay, let's move on to this one right here. Now 21 and 35 are not in my list, which means this is a multiple of one of these, and I've got to figure out which one. So here's the trick that I use. Ask yourself, what is the greatest common factor of 21 and 35? So here's where knowing your multiplication facts comes in handy. If you don't know your multiplication facts, it may be easier just to work it out the long way. 21 and 35 are both divisible by 7. 21 is 3 times 7. 35 is 5 times 7. I'm just going to write that down. Notice they have this common times 7 times 7. Okay? Look at the uncommon number, 3 and 5. Those numbers are part of a triple. And I look over here and I see, oh, 3, 4, 5 is a triple. 5 is the big one. It's the hypotenuse. It's in the right place. 3, 5, 4. This is a 3, 4, 5 triangle. So this third side that's unknown has to be, if we follow the same pattern, 4 times 7. So you see the 3, 4, 5. And then the times 7 is the common factor. What is 4 times 7? 28 feet. That's the length of the missing side. Now if you can do this multiplication trick in your head, you don't have to write anything down except the final answer. Let's try another one. Blank 10, 24x. 10 and 24, 10 and 24. I don't see that in any of these. So this must be a multiple of one of them. What is the biggest number that will divide evenly into 10 and 24? Well, they're both even numbers, so they'll both divide by 2. Alright, so this first one is 5 times 2. The second one is 12 times 2. 5 times 2 is 10. 12 times 2 is 24. There's a common times 2. If you look at the uncommon number, 5 and 12, 5 and 12 are part of this triple. The third number in the triple is 13, which means this third side has to be 13 times 2. 5, 12, 13. We've got it. And now what is 13 times 2? The side itself is 26 kilometers long. Again, if you can think through this multiplication in your head, you don't need to write down any work. And even though it takes some time to find that pattern, it still will be faster than writing down 10 squared plus 24 squared equals x squared and working out the entire problem. Let's do 3 more practice ones. So the next one here is 36 and 15, not in my list. Now remember, we need to memorize at least the first 4 of this list. Okay? It's not in the list. So I'm going to look for a multiple. What will divide evenly into 36 and 15? 3. 36 is 12 times 3. 15 is 5 times 3. So we got the 12 and the 5 as the uncommon number. 5, 12, 13 again. We're going to use that same triple. So that means the third side is 13 times 3, which is 39 feet. Final answer, 39 feet. Alright, next example. 24 and 40, not in my list of triples. Those are multiples. Okay. 24 and 40 will both divide by, they'll divide by 2, they'll divide by 4, 8. 8's biggest. 8 is the biggest common factor. So 24 is 8 times 3. 40 is 8 times 5. Now I got my common number first. It really doesn't matter. The 8 is common. The uncommon number is the 5 and the 3. 5 and 3 go with the 3, 4, 5 triple. That means this third side is 8 times 4. So 3, 4, 5 that's been multiplied by 8. And then 3 times 4 is 32. That is not a 32. I don't know what's going on. My brain and my hand are not working together. 32 inches is the length of the third side. Last but not least, one last example here. 48 and 50, not in my list. 48 and 50 are divisible by 2. That's the biggest thing. So this is 25 times 2, 24 times 2, 24 and 25 are part of this fourth triple right here, 7, 24, 25. That means this third side is 7 times 2, 7, 24, 25. 7 times 2 is 14 feet for the last side. Okay, so that's it for the day. Fishing for triples. Use that trick to save some time. On your practice packet, today you're going to complete the second page, which is actually labeled page 3 at the bottom. It's a page of fishing for triples, and I'll reiterate, you can use this shortcut or you can work them out the long way if you want to do so. There's 20 problems. They will take you very little time if you use the shortcut, a little bit longer if you have to work them out the long way. The only work that you really have to show on this worksheet is just filling in that third side. Do as much or as little in your head as you need to, and write down multiples like I did if you need. When you finish this, you're going to log into your Schoology, or you're going to go back to your Schoology, and you are going to complete quiz 2, which is a spot check of the work that you've done on your worksheet, and that will give you your daily grade. Okay, happy fishing!